This puzzle is called Contained Chaos by fritzdis. I got it from the Sudoku testing submissions channel of the CTC community Discord. Let's take a look at the rules. This is a chaos construction puzzle, so at first there's no regions, and we're going to have to build our own regions. And the regions must be connected, so we couldn't have like part of a region here and part of a region here, and have this be the same region. It has to be like, just one set of 9 cells all connected together. And then in each row, column, and region that we make, digits 1 through 9 must be placed once, exactly, each. Digits along arrows must sum to the digit in the connected circle. So, these 3 digits are going to add up to this digit. So if we found out that this was, let's say, 1, 2, and 5, this would have to be 8. Yeah, pretty straightforward there. Also, each circle plus arrow is contained entirely within one region. So, yeah, this is just one region here. I mean, obviously just 4 cells of it, but all in the same region. Okay, additionally, digits in circles indicate the number of cells in the region seen along the circle plus the arrow and extending out from the arrow tip. Okay. The circle with 2 connected arrows sees the indicated number of cells in both directions separately. Okay, so what that means is, let's say we have a 5 here. That means not only do these 3 digits add up to 5, but also um, these are all in the same all in the same region, and also that this region extends exactly enough to include this many cells. So 1, 2, 3, 4, 5. So this would have, whoops, I went light green. It has to go to there. And this has to be some other region. Yeah. Let's see. If the circle within row 9, column 2, I could have just done the example here, contained a 5, then row 9, column 2 through row 9, column 6 are all the same. Yeah, that's the same thing, although I did it with a curly one. Because this is a 5, all 5 of these cells are all in the same region. Yeah, and they can work backwards, so it'd be okay if all of these were in the same regions, but this cannot be in the same region. This must be something else. Yeah, and there we go. This is probably going to be pretty difficult. So this is version 2 of the puzzle. I tried version 1 and got stuck, like, after an hour or so. I made a lot of progress. It wasn't just, like, stuck at the very beginning. And in this version, Fritz just specifically says that uh, the version 2, this version 2 is intended to smooth out the later part of the solve. So yeah, that would be great because that was exactly where I got stuck. So hopefully I can get through it. Um, but probably still like a high 3 out of 5, if not a 4 out of 5, I think. Um, I'll put a link to the puzzle in the description down below if you want to give it a try. And yeah, let's hop to it. So the first thing I see, of course, is just highlight these different colors because we know each of these are different. Actually, yeah, we know this is a full. We know this is a full thing. So, is it possible that these two are the same? I almost just messed up right away. That would have been annoying. So, is it possible that green and blue are in the same region? And that's not the case. Um, so the minimum that 6 cells could add up to is if you put 1, 2, 3, 4, 5, 6 into them. It's the minimum amount for these cells. If they're all in the same region, that is, then these 2 cells, which are the sum of these cells, would have to add up to 21. So 1 through 6 adds up to 21. Just add 1 plus 2 plus 3 plus 4 plus 5 plus 6. So if all of these were in the same region, these 2 bulbs would have to add up to 21, which isn't possible. Even if you did 9 and 9, that's only 18. And of course you can't do 9 and 9 either, so. So these must be You can't have 2 3-cell arrows that don't overlap in the same region. They're just, the digits don't go large enough. So this one also must be a different region. It must be different from both of these. So now we have 3 regions, actually at least started. The next thing we can look at is what these arrows could be. So if we do 1, 2, 3 as the minimum, that's the least we can type into these cells, this bulb will equal 6. Because 1 plus 2 plus 3 equals 6. And it could be higher, so it's up to 9 there. Same for this, and same for this. Now, the other constraint is that this digit says the number of cells that are being put into this region. So, let's see, what's the maximum? That could be 1, 2, 3, 4, 5, 6, wait, 1, 2, 3, 4, 5, 6, 7. Yeah, so 7 is the maximum here. If this went all the way and touched the wall, this would be a 7, but it couldn't be an 8 or a 9. So it's 6 or 7, so we know these cells are in, and this one might be in. And it'll be the same case for this, I believe. Let's just check it. So 1, 2, 3, 4, 5, 6, 7. Right, it's a minimum of 6 cells. It could be up to a 7th cell. And then we could do the same for this one. 1, 2, 3, 4, 5, 6, 7. So this is also a 6 or 7. And reaches here, might reach here. Now, is there a way that we can... So I guess these all have a 1 and 2 on them. How am I going to write that? This is 1, 2, 3, 4. I don't know if this is helpful. 1, 2, 1, 2, 3, 4. Now, is it possible that these are the same? That some of these are the same? Like, could both of these be 6? That would make these 1, 2, 3. I think they could all be the same, actually. Could they all be 7? I think that would be fine too. These digits here would have to be either part of green or part of pink, but besides that, that would be fine if they were 7. It'd be like both of these were 7, because that would kind of block off access to this little set of cells. Well, yeah, I guess we can look at this. So what's the maximum number for this is 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so this is at most 8. Can't be 7, could be 6. Could be 5. 4. Yeah, it could be 4. Could not be 3. So this cell could not be a 1 or a 2. And let me just look at that real quick. Let's delete these for a second. So in the final puzzle, or in any Sudoku puzzle, every column and row and region has each digit once. So if we look at this column, we expect there to be 1, 1, and 1, 2. If we now include this column in what we're looking at, there's 2 1s and 2 2s. Let's just make that all gray for a second, even though that gray really makes it hard to see the arrows, but that doesn't matter. So in the gray region, there are 2 1s, 2 2s. Well, we have 1 1 and 1 2 in here no matter what. We have 1 1, 1 2 in here no matter what. So we can't put another 1 or another 2 in here. If we try to put a 1 here, then this is going to be a 1, and then we can't put a 1 in here, and suddenly this has to be a minimum of a 9, and this would shoot off the edge of the grid, and that's not allowed. And similarly, this one couldn't be a 1, because, yeah, it couldn't be a 1 because of the same reason. None of gray could be another 1 or another 2. So this this cell can't, right here, can't be a 1 or a 2. And let's just kind of undo those colors so we can get back our regions. Um, which means this could be like a 3-1 for 4, but it could not be a 2. Sorry, it could be a 1-3. Oh no, I didn't even see that 1 up there. Okay, so we're actually a little bit more reduced than I thought. So it can't even be 4. I was gonna say it could be 1-3 like this, because we just can't have a 1 in these two columns. But of course we can't have a 1 there because I just somehow didn't notice that literal 1 sitting right there. Okay, so minimum of 5. 1, 2, 3, 4, 5. Let's go dark green, I guess. And because I don't think these two cages, or sorry, these two regions are gonna touch at all, so that should be fine. So 5, and then these are kind of questionable. Um, but it's at least to here. Yeah, and what about up here? Um, we're gonna have the same kind of 1-2 restrictions on these two rows. I'll just highlight them gray for a second, but that really looks ugly. Let's do it this way. Again, we have a set of 1 and 2 being taken by this arrow, and a set of 1 and 2 being taken by this arrow. So we cannot put a 1 or a 2 at the end of this arrow right there. So this is, we can't have a 1 or 2 there, but we could have this be a 1 or a 2. So this could be 4, 5, 6, can't be 7 because of the 7 down here, could be 8. Because this one could be 1, 3. That would cause problems and make these couldn't both be 6 then, but that's fine. So this is at least 4, and we'll make this hot pink, I suppose. Think it'll be difficult to have these touch each other, so. And then down to here is possible. Okay, what? Oh, this is probably what I should have looked at first. This is going to be more important. I think I didn't see how this would be helpful, but they did mention this. The circle with 2 connected arrows sees the indicated number of cells in both directions separately. So if we tried to make this a 6 even, then this would see 6 cells in this direction. 1, 2, 3, 4, 5, and then this cell 6. And then also 1, 2, 3, 4, 5, 6 in this direction. That's a pretty big region, and if we actually just count it, that's 5 along the side, 5 along the side, and then 1 here. That's 11 digits in the region, and of course there's only 9 digits possible, so we can't do that big. So it's less than 5. Sorry, it's less than 6, so it's 5 or less. But it also has to be on an arrow, so we can't have 1 or 2 on here. Now, could we actually do 3 or 4? There's only one way to make 3, so we do this, and this is 1 or 2, but then this has to be the same, all the same region. So how do we add these up? We can't use 1, we can't use 2. That's impossible. And I guess we can highlight these first. If this is a 4, this is 1 and 3, but then how do we do the other arrow? We can't. I mean, there's only one. We can't use 2 twice or something, or use 0 and 4. Even if we could, those would double up, but that's doesn't really matter even. So we can't do 4. Can we do 5, or have we just totally messed up? So one of the options for 5 is 1 and 4. The other one is 2 and 3. And so now we can have 2 different options, but 5 we said was the absolute maximum. Whoops, what did I just do? 5 we said was the absolute maximum, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's 9 cells in the region, so we're done with yellow. We're done with yellow. Yellow can't take any more. So we've actually finished one region so far. Now what's interesting is we have this area down here. What regions can claim this area? Only this light pink and light blue, I believe. Light pink and light blue, that will be, let's just color those. So yeah, those are the only 2 regions that can get here, because they kind of block off this path, kind of, that would have been through here. So even if these were both 7, it looks like, whoops, I meant to press Z, not Windows key. I don't know if that oh, that didn't affect anything for you guys. I wasn't looking at OBS, but I meant to hit Z and I hit the window button, so something popped up on my screen above the puzzle. If both of these were 7, there would still be enough room in both regions to take 2 of the digits. So this would have 7 here, then let's just say 2 here, which would be the full 9, but that's fine. Then we have 7 here, and then 2 more here for blue, and that would also be fine. Oops. So we don't, so 7's work, that doesn't really reduce our options that much. I guess it does mean that in total for pink and blue, light pink and light blue, I should say, we have 6, sorry, we have 6, 12, 16 of the 18 digits fully accounted for. So there can only be like 1 cell of deviation from this between for each region. So I guess 2 cells in deviation total, which could include these 2 cells sticking out, but also could not include those. And actually, now that oh no, pink could take, So this space up here is a little fishy to me. Yellow can't go any farther. Yellow's done. So this dark pink could take 5 of these cells. 1, 2, 3, 4, 5. Oh no, that's just enough. And then light blue could take these. But then this wouldn't be taken. Okay. Okay, here's a question. Here's a question to ask. What if this cell is not pink? If this cell is not the dark pink, what region is it in? We've already finished yellow. If this cell is not dark pink, that means none of these are dark pink. And these aren't necessarily green, but what could reach here if not for dark pink? 1, 2, 3, 4, 5, 6, 7, 8, 9. This can only reach just around the corner. I mean, I believe this must be dark pink, and this must be dark pink, because nothing else can get there, right? This is 9. If green took every cell it could around this kind of back alleyway around yellow, we just can't get any farther. So these are at least, so this is at least a 6. And similarly for down here with green, what could take this cell? If green doesn't take this cell, what could take it? Yellow can't do it. Dark pink can get all the way around here, but that's it. So this must be dark green. That's the only option. And then these cells are, yeah, these cells are dark pink and dark green. One of these only reaches to here. Let's say it's dark green. Dark green could only reach to here, in which case dark pink would have to take everything else. Or dark pink only reaches to here, in which case only reaches to here, sorry. In which case dark green would have to go all the way around. Or could we have both of no, they couldn't both be 8s. They couldn't both be 8s. Because if both were 8s, then this 7 would be in both regions, which of course isn't possible. And they couldn't both be 6s. Because if they were both 6s, then we would have this kind of pocket of empty, regionless territory down here. Yeah, so one of these two is going to claim all 3 of these. Okay, that's good to know. And that region will be done. But then the other region will need to take 3 more cells. Okay. Okay, so now we can look back at dark pink for this weird region up here, or weird area, I should say. Region means something different. Weird area. So this dark pink is either done, or it can take 3 more cells. If it can take 3 more cells, if this is a 6, it could take 3 more cells. So we'll say, let's just say these 3 cells are dark pink. And we said between light pink and light blue, there can be 2 cells taken besides besides this, 2 cells can be taken. So if we gave all 4 of these cells to, wait, we can't even give all 4 of these cells to light pink because there's already 6 taken. If we give 3 of them to light pink, 1 of them to dark pink, sorry, 3 cells here to light pink, 1 of these to light blue, that would be 7 cells, then 2 of these could be light blue as well. Could be like this, but then if we make this yeah, we're gonna strand some cells here. If we make this a 7, we're gonna strand some cells, no matter what we do. Even if we give blue as many cells as possible over here, um, yeah, let's just look at what this looks like. So if this was 6 and we gave it as many cells as possible, made this 7 is going to leave some leftover cells here. So we have 1, 2, 3, 4, 5, 6, 7, 8, and we can take 1 more cell, but we can't. We're gonna have extra cells just left over here, no matter what. Even if we take as much space from over here as possible, which means we're running into problems, and there's gonna be another region that takes some cells in here, which means this can't be a 7 because the 7 is gonna block off access to those. So this can't be a 7. This must be a 6. Whoops, it must be a 6. I said. This is gonna be something else, and it can't be dark pink. So we can make this. Let's make this. What colors have I not used? Yeah, we can make this light yellow, I guess. That's fine. Yeah, I think that's good. This can't be a 6 then, but that's not much. I think the same situation might be going on down here. So if this was a 7, let's just start there. If this is a 7, then this is taken. And even if we give 6 of these cells to dark blue, and one of the cells has to go to dark pink, or light pink. Sorry, I cannot get colors correct for whatever reason, even though I'm like literally staring at them. So with this being a 7, this is the most cells available to it, which is literally just 1. Yeah, we already have 8 cells, so 1 of these could be light pink. So let's just say this is a light pink. Dark green could be a 6 and take 3 of these cells, but again, we have some leftovers. Even if we, tilt everything as much in our favor as possible, this breaks. So I don't think this can be a 7 either, because we're going to need another region to come down here, which maybe we can make gray. And we just can't get through here. Actually, let's make this region dark blue, but that doesn't really matter. We just can't get enough. Even if we made this, dark blue and this light pink, we just can't use all of these digits without these digits needing to get out. Yeah, so this must be a 6 as well, so this can't be taken. I believe this must be a dark blue, because it can't get... Dark green can't get over here. If dark green got over, let's say this was a 7. This would be... Oh, wait a minute, maybe we don't know that this is dark blue. Let me think about this. If this is a 7... Oops. If this was a 7, this could be light green. We could take 2 more cells down to there. Then we have our 2 cells of leeway between light green, between light blue and light pink. Both of these cells could be light pink, and that would work. Although we're now not... This isn't a full region down here. We only have 7 cells. So I think this... Long story short, this cell must be dark blue. If we try to make it if we try to make it light green, there's just not enough space. But now we have, what is this, 4? We now have 11 cells here. 9 of them will be dark blue. So 2 of these cells could not be dark blue, is I guess what I'm trying to say. Yeah, 2 of these cells can't be dark blue. which means that this can't be a 6. If this is a 6, we need to take 3 of these with dark green, and then we only have 8 cells left for dark blue. Yeah, even if we gave everything else to dark blue, that wouldn't be enough. So this must be the 8, which means green must curl around this corner down here. This is, whoops, this is a 6, I meant to say. Must go like that because of the 1-2-ness that I mentioned, I don't know, 15 minutes ago. So 3 of these are going to be dark pink. We don't know which, but we do need to have them allotted for eventually. This can't be a 6, I just noticed. Okay. Oh, this can't be oh, this could be 3-5 as well. That's fine. We don't need to worry about that arrow yet, I don't think. So none of these are dark green, because dark green is done, along with dark yellow. Both of those are done. Yeah, so either everything in here is going to be dark blue or light green or light pink. But there's some, like this one can't be light pink, and we already proved it can't be light green because there just wouldn't be enough room left. Only 2 cells can be taken. Oh, I didn't mean to make this one differently colored. It's just light green. Okay. So could this one not be... Yeah, if this is not dark blue, then that is taking 3 cells from dark blue. So that can't be dark blue. How could this be anything but dark blue? I think this whole area down here has to be dark blue. Because if something gets in here, it's going to cut off a lot more than just 2 cells. So all of these are dark blue. So we have 5 of the cells here. Oh, you know what? Actually, I might be mistaken here. Why couldn't dark blue come up through here? Oh, shoot. Yeah, I think I made a mistake. Let's scroll back a little bit. I think we need some other region in here. We established that. But dark blue could escape up here. Out of this region. Or out of this, like, secluded area down here. I was thinking that was filled, but that's not filled. So we could escape. Which is going to cause a little bit of complications, because, yeah, we could take 3 of these greens and then have blue just, keep going. Okay. Yeah, that definitely was a mistake. So let's just keep thinking. Well, this still can't be a 6. Okay, here's something. Okay, this actually... Unfortunately, I saw these steps just out of order, so I just undoed all through that. What happens if this digit is a 6? Now we can't put a 6 in yellow at all. So this must be a 7. Which means this must be taken. Which now we can repeat all the logic we just did. So I think it was... These are all dark blue. And this is an 8, this is a 6. Because now dark blue is definitely trapped in here. Yeah, I missed that little bit. And the gray slash definitely confused me a little bit. Yeah, but that's fine. We figured this out. So this is this. I think that's good. This is what are 2, this is a 4 or 5. Okay. We have this. Now 4 of these cells are dark blue and 2 of them are not dark blue. Could this one not be dark blue? I don't think so, because if light pink comes here, then it would block off 4 cells. So this is dark pink. Sorry. So this is dark blue. Yeah, these 2 could be fine. You could even take this, and that would be fine because we would still get the full number for the region. Okay. That looks good. So neither of these can be 7. Okay, so this can't be light green, actually. Because we just placed the 7 in light green, so this is something else. And nothing... Wait, could this be light yellow? 1, 2, 3, 4, 5, 6, 7, 8. This could be theoretically light yellow. Although, then how do we fill this? If we made this light yellow, how do we then fill this area? I don't think we can. Let me count here real quick. Yeah, we only have 8 regions so far. So we need a whole another 9th region, which looks to me like it's going to go up here. Whoops, not in there. It's going to go in here. So if we made this light yellow, we would be taking way too many cells away from that new region or the last region. So we would only have 8 cells left for this last region. So this must be the last region, which let's actually switch these because there's a chance that these two could touch, and I don't want to talk about logic of light yellow versus dark yellow. That's just recipe for disaster based on just how badly I've been naming colors so far this video. So yeah, gray now must come into this area at least a little bit. It can't take that much. Um, because 3 of these cells are also going to be dark pink. And then this area up here is going to be split between gray, light yellow, with possibly a little bit of light blue and light green coming into play. Okay. I think this could be light yellow or gray, either. Because if we did have gray come all the way over here, there's 10 cells available to light yellow, which is obviously one more than enough. Okay. Do we need to start trying to do some Sudoku with this? We've already had to use a little with this kind of right angle region here, the yellow. How does 6 go down here? 6 must go here. Or sorry, 6 can't go here, can't go here. Can't go here because 6 would put a 2 on here, and we've said before that this cell can't be a 4. Sorry, it can't be a 2. Where did the 4 come from? It can't be a 4 either, I guess, but I meant to say 2. This can't be... Neither of these can be 6, so we've limited 6 to one of these 3. Okay. Actually, where does 6 go in this column? It can't go in light blue or light pink. It can't go in yellow, so we've actually limited 6 to just 2 spots in this column in full. Although, I don't know how helpful that is. But we've done it. That's the important thing, I guess. I don't know how to illustrate that or mark that on the map in any way that's useful. This can also be, I suppose, either one. I guess are 1s and 2s constricted up here? No, oh no, this could be... I was thinking pink was going to... So in the top 3, in these 3 rows, there's going to be 3 copies of the digits 1 and 2. One in row 1, one pair in row 1 that's already in the grid, 1 pair in row 2, and 1 pair in row 3. Yeah, I mean, that's just how Sudoku works. There's going to be 3 1s and 3 2s. So 2 of those are going to go to gray, 2 of those are going to go to light yellow, 1 of them, at least, is going to go to dark pink. But could anything else... I guess the other one is going to go to dark pink, so none of these could be 1 or 2. We're going to have another 1 or 2 I guess not here, but in one of these cells, we're going to have a second 1 and 2 for dark pink, for whatever that's worth. I don't I don't see what that's worth, but it's something I noticed. Oh, here's something. Okay, so I didn't see how this was helpful, but these two cells are the same. Because, of course, let's say this is a 9. Where can we then put 9 in dark green? Well, we can't put it anywhere in the bottom row, so it must go there. And we can just keep using this 9 example, that's fine. So now where does 9 go in yellow? This is the part that I didn't see immediately. It can't go down here, so the 9 must be up here, pointing upwards. And this works the same no matter what the digit is besides 5, I guess. If this was a 2, okay, well, it can't be a 2. Okay, a 3, um, then we're talking 3 pointing up here. The important part is that whatever digit we put into these two cells, which we can maybe label black for the moment, is going to be pointing upwards. Now, where does the black cell go in dark pink? Because it now can't go in columns 9 or columns 8. Or, yeah, column 9 or column 8. So it must go into column 7 here. So, and if it tried to be this, yeah, if it tried to be this, then we wouldn't have enough room for everything else. Because like these cells, we would only have 16 cells, 3 by 5 plus 1. 16 cells for 2 full regions, so this can't be dark pink. So one of these is a dark pink, and one of them is black. Now there could be, both of these could be dark pink. And it could be like, well, it couldn't be like that, I suppose. It could be like this. Or it could just be these two across here, and then have light blue take both of these, or maybe something like this, and just one extra cell from light blue. But one of those is that cell, and what could this be? It could be any of the little digits. No, it can't be a 2. It can't be a 5, can't be a 6, can't be a 7, can't be an 8, could be a 9. So it's actually almost, oh, this, yeah, we'll just kind of remember that this is the black cell, I guess. Um, it's almost likely that it's this little digit, for whatever that's worth. Because there's only 9 as a big digit as possible. Can we do that with any other regions? Because I guess if we put black back, now where does that digit go in light blue? Could be anywhere along here. I guess it couldn't be here because that would block light pink from taking any cells, and it has to take at least one. Or it could be over here, possibly even over here. Okay, so I don't know if continuing to look at that farther over is helpful or not. Oops. Yeah. I was hitting undo and I wanted to undo the undo. If this is 4, I think that works just fine. 4, 4, yeah, and 1, 2, then this will be a 3. That works just fine, yeah. I thought maybe, I didn't see how, but I thought maybe throwing another little digit in to this kind of mess of little digits would cause some problems. Okay. So what can these cells, oh, here's something. What can these cells be? Can It could be a 3, a 5, an 8, or a 9. But most importantly, it can't be a 6. 6 is very constrained. So wherever this pops out, it needs to take a 6. Okay, I say that, but then actually that's pretty easy. Because we could take a 6 down here or up here. Okay. Thought it would be slightly more constrained there, but it does not seem to be. Okay, could this have both 3 and 5? Let's say this didn't have a 9. If this was 3, 5, 8, I feel like that's going to cause problems because this is going to force to be a 4, which is going to force this to be a 1, 2, which is going to force this to be a 3. So we can't take 8 and 9. So we can't have both 3 and 5 here. It must be 8 and 9. Yeah, because otherwise there's already 4 digits that are 5 or less, so we can't then put 2 more in. So this must have an 8 and a 9 in here. Or another way we could have asked this without even looking at this is where can 7 go in this row? We have 7 ruled out of light green. These can't be 7, so this must be the 7. Which, okay, that's actually a good question too. We have this black digit that must be over here. But now, where does 7 go in dark pink? It also can't go in these cells. So it's going to be placed over here. And actually this 7 means this must be a 7. So this must be the black cell. So so this must be in. This must be dark pink. Which means this must be dark pink. So I think dark pink is done. 1, 2, 3, plus 6, yeah. So this is black, whatever that color, or whatever that digit is. This is dark, or this is black in dark pink. I don't know if that's helpful. That black does look a little weird, so I don't know if I want that. So none of these cells up here can be dark pink. So it must be gray. I think that's the only thing. Yeah, that's the only thing that can reach there, of course. So now we have, so this can't be dark pink. Sorry, this can't be gray anymore. Which means this must be light yellow, because even if it looped around, then we would leave kind of a, regionless cell there. This must come out of its little cubby hole down here, or back here. How many is that? That's 6. So it needs to take 3 more cells from here. How many is this? This is 14 cells, 3 by 5 minus 1. I guess we could count, we have 3 by 5 here. So that's 15 cells. We've already allotted, how do I want to, we have 3 by 5 here. That's 15, plus 5 more, that's 20. We have 2 full regions in here, so that's 18 cells. So 2 cells in here are going to be claimed by either light blue or light green. It doesn't have to be, like, I think it could be 2 light greens down here. Dark blue takes all of this. That kind of forces these to be 2 light blues, or maybe forces these to be 2 light blues. So I think, yeah, I think we have some options, I guess I should say. Yeah, we have some options. Okay. We do have a lot of 7s now all of a sudden. Can we do anything with 7? So 7 in light blue. Light blue can't get up to row 1 to take a 7 up there, but it's currently blocked from being a 7. Any of these cells are blocked from being a 7. That only leaves 2 possible cells. So one of these is a blue 7, and it can't be this one. If this was light blue, oh no, this could be light blue. If light blue went like this, but both of these can't be light blue. One of them can be light blue, yeah. But anyway, whichever one it is, it's a, whichever one light blue is in this set of 2 cells is a 7. I guess in row 1 we need to give gray a 7, and it can't be in here. Now it can't be here. Can't be here. Of course, neither of these are 7s. So I guess we only have 2 options in row 1 for a 7. So one of these is a, no. One of this or this is a 7. Could this be the gray 7? That seems pretty far over. That does seem pretty far over. Actually, maybe a better question would be, where can 7 go in this column? We've already put 7 in yellow. These can't be 7 because they're just not 7, and neither are these, and neither can this because we already have a 7 in the region. We have 7s in the rows, ruling those out, so that's the 7. So now we still need a 7 in column 2 and column 3, and those will be the light pink and the dark blue 7s. But we don't know, like, which is which, or really... I guess we know that they're going to be in this region, this area, which doesn't really offer that much insight, but it's a little bit of insight. Hmm. So this black digit is going to go here and here, somewhere in here, because it can't be a 7. What about 6s? We have a lot of 6s as well, and 6s have provided some help. Um, no, I think this could be a 6. I was going to say that 6 was a bit ruled out of this column, but it's not ruled out that much. Fortunately, things start to open up on this side of the grid. This can't be a 6, this can't. I think this could. Well, those, obviously a 1 is not a 6, that's pretty clear, at least. These could be 6s. This could be a 6. Ooh, there we go. What about this row? This can't be a 6 because of the column. This can't be a 6 because we've already ruled 6 out of there because it has to be less than 5 to add up to 5. It's not on light pink or light blue, so this must be a 6. Okay, that's a bit helpful. Oh no, I was gonna say where does 6 go in light green? But it can literally just be right here. It doesn't have to like shoot up the same way dark pink had to shoot over. In fact, it can't shoot up because there's a 6 in row 2 already. Hmm. So what are the 2 cells that are going to be added to green? It's going to be a 3 or a 5, and then it's going to be a 6. Yeah, that doesn't help, I don't think. Um, so what are the options here? I guess it can't be 1 7. It could be 2 6. It could be it could be 3 5. If this was a 3, does that cause problems? I don't think so. It almost causes problems. It kind of figures out how everything looks in these 1 2 3 4s, but it doesn't actually cause a problem. If this is a 6, then we put a 6 here. Which then, does that make it hard for gray to get a 6? Where can 6 be at the moment? Maybe we should highlight that. We have this row, or this column done. Could be here, could be here. Nope, there. Okay. Let's just make these black for the moment. Actually, how could this be black? That's just not possible because any region that takes this cell already has a 6 in it. So that's just not possible. This could be a 6 and have it be green, light green though. Okay, so if this is a 6, this must be a 6, this must be a 6. Then we have a 6 along here. I guess not there. I feel like I've not put a 6 in one of the regions yet. Did I forget to highlight something? Okay, here's a question. Here's a better question. I talked about this with 1s and 2s earlier, but I think the same question holds for 6. So in rows, yeah, let's get rid of this for a second. In rows 1, 2, and 3, we have 1 6 in each row. That means we have 3 6s in total. We can't have any more 6s up here, right? We have 3 6s in total because we have 3 rows. Yeah, sorry, I was convincing myself, not explaining to you. But we've already claimed one of them with this dark pink 6. Now we have 2 6s, and we need 1 for gray, and we need 1 for light yellow. That means that we can't have any more 6s up here. So before I was saying that 7 could claim a 6 up here, that's not actually true. One of these must be 6s for light green. And I don't know which, but one of them must be. Because if we put it up here, then there would only be 2 6s left for 3 regions, or one 6 left for 2 regions, since we've already claimed 1. Yeah, so it must be down here. So this is not a 6. This must be the 6, which rules a 6 out of here, and a 2 out of here, 3 out of our black cell, so it's not just 1, 4, or 9, for whatever that's worth. This is a 3, 5. So we have 6 here or here. I guess I could color these, and these are not that color. Undo. Dark blue, light pink, yeah. Oh, so now this can't be light pink anymore because one of these must be a 6. That's one of the 2 cells that could not be dark blue. So this must be dark blue. Okay. Yeah, I think that's fine. I was just looking at these because we now have kind of an angular region here, which means that kind of the same way yellow is. So if we have like these 2s and 7s are looking down here, ruling it out from here. So I was thinking maybe that there was like going to be a forced 2 or 7, and also this 7 rules it out of up here, but we still kind of have 4 cells left for 7 in dark blue. So that's not super helpful, but definitely something to keep in mind, I think. Okay, so 6s are along here. This column already has one. Here, these columns have them. Can't be anywhere along here. Could be here. Could be here. Okay, so we're very limited on the number of 6s that are left. But I don't know if we're limited enough to do anything. I guess one of these must be a 6. Right? One of these must be a 6. Because those are the only possible spots for a 6 in the row. And this is not a light blue 6, so this must be... this must it be light yellow? I was going to say it must be light yellow, but could... 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, these are... Whichever one is here is the light yellow 6. But one of the other cell could be light green, I think. Where have we not placed 7s? It seems like we've placed a lot of 7s, but not enough. I think, is it just dark blue and light pink? how many sevens do we have? 1, 2, 3, 4, 5, which is light blue. 6, 7. Yeah, we need to place two sevens in here. And one of them must be in light pink. So the 7 in light pink is in here. Which, for whatever it's worth, means that the 7 in dark blue is not also in here, because that will be two sevens for rows, what is that, 6 and 7? Which means we couldn't put a third 7 in here. Or a better way to look at that is, where could we put a 7 in row 8? It must be in one of these two spots because we have this 7 looking down. Okay, that's something at least. Reducing some options, always a good thing. We already know the 6 is in there for light yellow. And then we have, we have this little, I guess we could pencil mark this. 6 for gray is up here. Oh, wait a minute, didn't we say... Oh, no, that doesn't... I was going to say, one of these is a 1 or a 2. Actually, these are 1 and... Both 1s and 2s in dark pink are up here. We said this earlier with, when we were looking at 1s and 2s in the first 3 rows. There's going to be 3 1s, 3 2s up here. That's it. And it's exactly that much. We can't have less, obviously, because we have 3 rows. So we have 2 2s and 2 1s in gray and light yellow, which means we need 1 more 1 and 1 more 2. But what other regions are up here that can take a 1 or a 2? It's only dark pink. So 1 and 2 are going to be up here, for whatever that's worth. For a second I thought that it meant that this must be a 1 or a 2, but I don't think it does, because the black cell, which goes here, could be a 1. So actually, I don't think this could be a 2. So if this was a 2, that would imply that this is a 2, which implies this is a 2, and that can't be a 2. Okay. Hmm. Hmm. Not sure where to look here. Yeah, we have most of the 7s. There's a 7 in here. So what are these 3 digits? There's an 8 and a 9, and then there's 1 5 or less. But the important thing is the 8 or 9, maybe? Does that mean anything? I don't see what it means. One of these is a 5. That's fine. Where can 2 go in dark blue, maybe? We have this 2 looking down, and we have this mess of 2s, and just mess of low digits, really, blocking 2 out of up here, which means 2 is going to be in here somewhere. Can we reduce those possibilities from 4 cells? I was hoping we could figure out that neither of these were 2, which would give us a little bit of information, but I don't see how to do that. Because, yeah, if we could rule 2 out of these 2 cells, then this would be a 2-7 pair. Which would then, yeah, which would actually do a lot, because then 2 in yellow would be forced here, and 2, this would be forced to be a 2, which would force this to be a 4, and, give us a lot of information, actually. Um, if one of these is a 2, does it, yeah, just, and actually that would make this a 1-4, and make this a 9, because this has to add to 5, which I haven't really been thinking about, that fact. Yeah, for a while I was thinking that this could be like a 1-2, but that's just not possible. This is something that adds to 5, same as this. I don't know if I can make use of that fact. Okay, what happens if this is 1-4? Because that does... If this is 1-4... Sorry, no. If this is 1-4, then this is a 9, this is a 9, this is a 9. Puts a 2, 4, 9, 1, 8. That does so much, but I don't see why... I mean, I've only been glancing for a second, but I don't see why that would break. It means this is not a 1 because 1 has to be up here for this triple. It certainly does a lot immediately if that's a 1 and a 4. But I don't see why that has to be a 1 and 4. Or why it would break, why it couldn't be a 1 and 4. And if this is a 2 and 3, that doesn't really do anywhere near the same amount that I see. I guess it rules 1 out of here. So this would be a 1-2 pair, this would be a 4 or a 9. Which means this is never a 1. How can I prove that nicely? If this is a 2-3... Sorry, if this is not a 2-3, then this is a 9, this is a 9. In which case, this is not a 1. If this is a 2-3... How did I figure out that that was not a 1? Did I just make that up, maybe? This can't be a 2 or 3, but it couldn't have been a 2 or 3 already. I might have just made up the fact that this couldn't be a 1 in this case. I don't see why this being a 1 would break anything. I thought I was onto something, because that would have forced this to be a 1-2 pair if this couldn't be a 1 in either case. So we need to put, what, what can these 2 cells be? They can be 1, no, what can this cell be, I guess? This can't be a 1, can't be a 2 because of all of these low digits. Can't be a 3, could be a 4, can't be a 5, can't be a 6, can't be a 7, can't be an 8, could be a 9. So that's actually just 4 or 9? What about this cell? Is that also pretty restricted? I don't think so, because I think this could be a 1 or a 2. Not a 3. Could be a 4. Not a 5. Not a 6, 7, 8. So this has a number of options. If we could rule 2 out of here, then we would have a triple in green, which would be nice. But we don't quite have that. What happens if this is a 2? Then this is a 1-4. And we go through that whole 1-4 mess again. Because now we have a 2 looking down, so neither of these could be 2, so it must be 1-4. So this is just a 9, so this is a 4. This is a 6-1. So this would be the 6, this would be the 1. Which makes this a not, which does break the puzzle, but that's like after 15 steps. Is there a better way that I could... see that? Whoops, no, now I'm removing stuff I wanted. Is there a better way? So where can 1 go in this, in green? It can be in any 4 of these cells. This is a 1, then one of those is a 1, this is a 1. Makes one of these a 1. Oh, no, that puts a 1 there. Never mind. I was going to say it breaks blue, but no, that puts the 1 in the corner. Ah, that doesn't quite do anything. Darn it. What if this is a 1? That should... Does this have to be a 1 or... If this is a 1, that breaks the puzzle. If this is a 1, this is a 2, 3. This is not a 1, so this is a 4 or a 9. This cannot be a 1 or a 2. Now we only have 1 spot for 1 and 2 in the whole cage. Because we need to, because of the, like, the row 1, 2, 3-ness thing. This has to, we had to have a 1 or 2 up here. We're ruling out of here and ruling out of here, which breaks the puzzle. Okay. So this can't be a 1. I guess I could just type in that this is 1, 4, or 9. But I don't see... Yeah, I don't... If this is a... If this is a 1... This is a 1, which makes this not a 1, which makes this a 1, which puts a 1 here. It makes this a 2, it makes this a 4 or a 9. Does that matter? I guess this has to be a 6, this has to be a 2. Yeah, I don't know, this is just going down a rabbit hole here, okay. So any of these 3 digits is 2. Can we cause the same problem by making one of those a 2? Hmm. Sorry, my throat was getting dry, I had to take a drink. If this is a 2, we're gonna run into problems. Maybe. This is a 2, this is not 2 or 3, so this is 1 or 4. This can't be 1 or 2, so this is 2. So this must be the 1, which makes this a 1. Actually, does that cause any problems? That might not actually, that might be a false alarm. That might not actually cause any problems. Makes this a 6, this is a 4 or 9. Maybe I'm getting too caught up in just, like, specific options. Because I did see right at the last, you might have seen me highlight this. This cell is either, I guess it could be here. If it's a 9, then it could be here. But it's all, or down here. Does that mean anything? It does mean a little bit. If it, oh, but it could be up here, which would kind of break everything. If this is forced to be down here, if this is an 8, I guess, then it's it down here. And then also we have to put that same digit, the 8, into light pink, which means it must be along here in dark blue. Yeah, I guess. Oh, that's one way of looking. These 4 digits are these 4 digits. Because we can't put them anywhere else in the row. We can't put them in yellow, so they must be somewhere else in the row. So these 4 digits are these 4 digits. And we already put the 7 there. There could be an 8 or a 9, but this could also just be the 9. But there needs to be an 8. Oh, no, no, it doesn't need to be an 8 because it could be the 9. And then there's... Could this be 2, 3 over here? Maybe that's a question? Because if this was 2, 3... Whoops. This would be a 9. So then this would be 2, 3, 7. And this... So this would just be a 3. And this would be an 8. I don't see that that's a problem. On this side... Okay, what about this way? The non-yellow digits are these. So we need an 8 or a 9 up here somewhere. But that's not terribly hard to figure out. Here's an interesting thought. Maybe. So this pair has a 1 or a 2 in it because it has to add to 5. It's either 1, 4, 2, 3. Has to have a 1 or 2. This has a 1 or 2, so one of 1 or 2 will be ruled out from here. So this couldn't be a 1-2 pair, basically. So if we made this a 6, then this would necessarily have a 2 down here, which means that 2 couldn't be the ruled out digit, which means that 1 couldn't be here. So if this is a 6, this must be a 1, which puts a 1 here. Which then rules out 1, doesn't it? Which means 1 is looking... We now have 2 1s in the columns and 2 2s in the columns. Right? Let me think about that again. Okay, if this is a 6, 2 must be in here. Which means 2's match up with these 2's, and we can't put a third 2 within 2 columns. So that means these can't be 2's. Which now means we have 1's matched up here. And means these can't be 1's, which puts a 1 here, but then we just literally put the 1 into the row. Okay, whoops. So this can't be a 6. This must be a 6, which means this is not a 6, this is a 6. Okay, so we got some digits here. So this is 1, 2, 4, or 9. That's what's left. Although it can't be a 1 because that causes issues. Yeah, if this was a 1, this would be 2, 3. This would be a 2, this would be a 1, which puts a 1 here, which is already in the same region, yeah. I feel like we're close to... Is there more that I could do with these? Maybe there's more that I can do with these regions. I mean, this could be gray. I guess this must be light yellow. I don't know how much that helps, though. That doesn't seem that... Because we couldn't reach gray here. Gray is a maximum range of, like, here. Sorry, of here. Or, like, this. This last digit could swing a little bit. Or we could swing twice and go like this or this. Probably not like that, I guess. But, yeah. Oh, wait a minute. So, one of these is light green. Oh, but no, but both of them could be light green. No. Yeah, both of these could be light green. I haven't said that this is light green up here. Both of these could be light green. Yeah, maybe this coloring is gonna throw me off. I'm not sure. Let's delete that for a second. So one of these does not have to be light green. Both of these could be light green, in which case both of these are blue. In which case 3 of these are light pink, and this is light blue, and then we need to take 2 light blues up here. I think that would work just fine. I think this can only be 4, 5, or 9. No, it could be a 7. Darn it. Okay, that's not helpful. If this is a 4, this is a 4, this is a 3. I don't know, that doesn't really seem to be looking anywhere. Oh, that's a... If this is not a 1 or a 2... Oh no, this could be a 1. Never mind. I was just thinking, like, we're actually kind of running low on places 1s and 2s can go in these two columns now. Like, we have 4 total 1s and 2s in these two columns. 2 2s, 2 1s. So we put 2 of them in here, 1 of them in here. These can't be 1 or 2, these can't be 1 or 2, these can't be 1 or 2. This can't be 1 or 2. None of these can be 1 or 2 because we've already put all the 1s and 2s in light pink and light pink and light blue. So now we only have 2 spots. One of these 2 is a 1 or a 2. But not both. They can't both be a 1 or a 2. Because we definitely have 3 1s and 2s already allotted. If this is a 2, by pencil marks that puts a 1 here, which puts a 1 here, and now we have 5 1s and 2s when we need 4. So this can't be a 2. So this is a 2, which is going to do a bit at least. Maybe not a lot, a bit. Maybe not as much as I hoped. What are these digits, I guess? This is an 8, 9. Oh, this can't be a 2, of course. So that does do a bit more. So these can't be 4, so this can't be a 4. Yeah, what are these two? This is a 3, 8, 9, and one of them must be a 3. I don't want to pencil mark that because that is across regions, but yeah, 3, 8, 9 is fine. Okay, so the one other thing I saw is now 2 in dark blue is very constricted. It can't be along here because of the given 2. It can't be up here because of all the 2s up here. And it can't be in here because of the 2s in yellow now. So there's a 2 in here, which means this is not a 2. One of these is a 2. I don't know how hopeful that is. I'm getting a phone call actually that I have to take, so I'll be right back. Okay, sorry about that. Just a quick phone call that I was expecting and I had to take. Okay, where were we? 2's in here, which doesn't really force much. I guess that is the... Yeah, no, we didn't... Both of these could be light green, so both of these could be dark blue. Yeah, okay. Oh, this can't be an 8. That's been sitting there for years, although it doesn't really matter. Oh, this 4, that's gonna be huge. So these can't be 3s, so this... I don't need the 8, 9 markings anymore. Okay, well this wasn't as huge as I was hoping, but it was very helpful. No, it is huge. This is now a 9, which makes this 1, this 1, this 1, this 4. So this is an 8, so this is a 9, so these are not 9s. Puts a 9 in one of these. What are these 3 then? We've already put the 1 in the row, so this is 4, 7, 9. And this can't be a 7. Okay. What is left in this region? We need a 3, not a 4, we need a 5, not a 6, not a 7. We need an 8, and we need a 9. Is any of that ruled out? I don't think so. That's a 3 or 8. These are gonna be the same digit. You could ask, where can this digit go in dark pink? And it must be right here, because it's not a 1 or a 7. Okay. So I guess there's a 5 in one of these two cells, for whatever that's worth. Oh, there's a 3 right here. So this is a 2, 3, this is a 1, 2. Oh, I guess there was a 1 right here that would have helped me out there as well. Okay, what's left in this column? We 1, 2, 3, 4, 5, 8, 9. And this can't be an 8 because we've already we already have an 8 in that region. Okay. But this 8 could be part of light blue or light pink. We don't know which. Okay. Although now we are getting a bit congested on 1s and 2s. So where can 2 go in gray? Let's start looking at that. How do I? So it's going to be somewhere in row 2. So it's initially one of these cells could be the 2 in gray. And neither of these can be a 2 because of all the 2s here. And actually we can clean this up a little bit. But first of all, most importantly, this must be a 2. And it must be gray because that's the only spot in row 2 that can be a 2 and be gray. Which puts the 2 here, which makes this blue. Now, I said we could clean this up. This is a triple here, which means the 3 is in one of these two spots, which means this can't be a 3. Which just gives us a 1, 2 pair, and we finish off the column with a 3, 5. Which means the 3 is not light blue, but the 5 could be light blue. Okay, I don't know. I don't know. Oh, now we have a 3. 3's looking down, of course, with this triple. Means this is a 5, this is a 3. So what are these 3 cells? This is 4, 8, 9. Because we have 1, 2, 3 triple, then 4, 5, 6, 7, then 8, 9. Yeah. Oh no, this could be an 8. If this was gray, it couldn't be an 8. But gray could go through the 1 or come around the 1. Or avoid the 1, I mean, and avoid this cell both. So I don't think we quite know. Maybe we know this isn't gray though. This must be like yellow because 1, then 7 would be 8, then this would be 9. Yeah, we can't take that cell as well. And actually, oh no, well one of these could be, yeah, one of these could be light green, but we don't know which. Or we don't know if that's the case. Okay. We're cruising. We just need to not lose some steam here. What could this digit be? It can't be a 1. Can't be a 2. We've already put 2 in gray. It can't be 3. Could be 4. Could be 5. Darn it. 6, 7. Could even, no, it can't be 8. But it could be 9. Darn. It looked more restricted than that. It definitely looked more restricted than that. Okay. Where can 1 go in this column? Or sorry, in this row? 1, okay, let me just double check that. I think 1 is forced all the way over there. So these are not 1s. This is not a 1. Light blue already has a 1, or the column. We've pencil marked those. Yeah, 1 must be over here, so this must be gray. Which means this must be gray, because otherwise, I think it could, theoretically, by the numbers, avoid that cell, but maybe not actually. But either way, it would leave just a regionless cell, so this must be gray. It means it's not 8. That's 1, 2, 3, 4. That's all of gray. We have a 4, 5, 9 triple. This is a 3 or an 8. And it can't be an 8, so this must be a 3. So this is an 8, this is a 3, this is an 8. No 8s down here. This can't be an 8, which gives us an 8 in that row. Or in that column. Because we had a triple there and we ruled 8 out of both of those. So this must be light pink. No. That's definitely not light pink. Light yellow. Because we've already put the 8 into these two up here. So this must be all light yellow. 1, 2, 3, 4. That's all of light yellow. So these two are, let me think how this must be. I don't think we know for sure. It's not 1 and 1. This couldn't be light green at least. So this must be light blue, which makes this a 5, which makes this a 3. Um, which means it can't be blue actually. Okay, there we go. Now we figured things out. This must be the 6 because if we put the 6 here, this cell could not be dark blue because yeah, it would just be kind of segregated from the rest of its region. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Okay, this can't be a 6, of course. Oh, this couldn't be a 1, so this is a 1. I just missed that one down there when I was looking at that stuff. Didn't really affect the solving process, but definitely something I should have noticed because it could have affected the solving process. And just like, not that it was a mistake, but just like, hey, that rules out another position, which, could have been important. This is a 4 or 9 for the row. This is a 4 or 9 as well. So we now have a 4 or 9 pair in the column. So this is a 5, this is a 9, this is a 4, 9, 4, 9, 4. This can't be a 5. That doesn't matter. Okay, that's fine. This is a 3, 5, 8 in the row. This can't be an 8, so this is an 8, and it can't be a 3. So it's a 5. So this is a 9, 8, 5. This is a 3. Okay. Now we have a 4 here, so this is a 9. There's not a 4 or a 7 up here. So this is a 4 or a 7 in the column. Oh, this is just a freebie. Probably a 3? Yeah, 3, which gives us a 1, 2, 3 here. 2, 1 there. 1, 4 there. Okay, let's just take 9s out of there. This is 7, 8. And this is 4, 7, 9. Okay. Now let's kind of figure out things. This can't be dark blue because dark blue already has a 9. We now have a 4, 7 pair in pink, so this is a 9. Which is going to just resolve some stuff, and we'll finish the numbering, and then we'll finish the regions. Okay. We already have a pink 7, so that can't be pink. We already have a blue 5, so that can't be blue. So this must... No. How do we know which is which? Oh, of course, because light pink must connect to all of its cells. There we go. That was tough. Maybe that was even higher than 4 out of 5. I don't know, but I feel like I was missing something when I was like checking the options for down here. I feel like I was missing something like more global, if that's the right term. Uh, yeah, something like that. There's, but I did get through it, and I'm happy about that. I do like fritzdis's puzzles. They definitely make hard puzzles. At least most of the ones that I've done have been pretty hard. And this was no exception. But I do like the chaos construction constraint. If that's even is it really a constraint when it like opens up the puzzle? I don't know. But it is a lot of fun to try to figure out where the regions go and then use that. So thank you for this puzzle, fritzdis. Definitely like a 4 or 5 out of 5. But doable, obviously. I just did it. And thank you all for watching.